Hello everyone, welcome to my YouTube channel Smartrix for Study. In this today's class, we will learn electric charges and field purely MCQ. So let's get started. So the first question is electric field at a distance r from infinitely long straight uniformly charged wire is, so option 1, inversely proportional to r, inversely proportional to cube of r, inversely proportional to the square of r, and independent of r. So we have the formula E equal to 1 by 2 pi epsilon naught lambda by r, where lambda is linear charge density and r is radius of the cylinder. So from this formula, we'll get to know option A is correct, that is inversely proportional to r. Let's move to the second question, that is electrostatic force between two charges in a vacuum is given by F equal to K Q1 Q2 divided by R square, where K is. So from this option A is correct. 9 into 10 to the power 9 meter square per coulomb square. So let's move to the third question. When a free electric dipole placed in a non-uniform electric field, the dipole will experience option A, both force and torque, option B, only force but not a torque, option C, only torque but not a force, option D, neither torque nor a force. So we know that when we keep electric dipole in a uniform electric field, the electric dipole experience only torque, but when electric dipole placed in a non-uniform electric field, the dipole will experience both torque as well as a force because of non-uniform electric field. Thus, option A is correct. Let's move to the next question. Question number 4. The direction of electric field vector at a point on an equatorial plane of a dipole is option A, in the same direction of the dipole moment, option B, in the opposite direction to the dipole moment, C, towards the negative charge, option D, towards the positive charge. So option B is correct, which is in opposite direction to the dipole moment. Next, fifth question. The given figure is related to the Gauss law in electrostatic. Phi equal to Q by epsilon naught, where Q is equal to. We know that Gauss law is stated as electric flux to the closed surface is proportional to the net charge enclosed by the surface. Here in this surface, the charge enclosed in the surface is minus 2 microcoulomb and plus 8 microcoulomb. From this, we will get what? 6 microcoulomb, means positive 6 microcoulomb. So option D is correct. Next, SI unit of electric flux is option C, that is Newton per coulomb meter square. Seventh question. The following figure shows that electric field around the two charges where Q1 is positive, Q2 is negative. Option B, Q1 is negative, Q2 is positive. Both are positive and both are negative. See, in this figure, Q1 and Q2 charges are there in which electric field are outwards. So we know that electric field is outward for what? Only positive charge. And electric field is inward for only negative charge. Hence, we come to conclusion that Q1 and Q2 both are what? Positive charge. So option C is correct. Next, electrostatic field lines can never form a closed loop. This is due to option A, conservation of charge, option B, conservation of momentum, quantization of electric charge, conservative nature of a electrostatic field. So option D is correct, conservative nature of electrostatic field, because the positive charge electric field originates from the positive end and ends at negative end. Hence option D is correct. Next, ninth question. Electric field intensity at a distance r from center of uniformly charged sphere outside the sphere is E. Which one of the following is correct? This question is directly from what equation only. So option C is correct, where electric field is directly proportional to the charge and inversely proportional to square of the distance between that. Last question. Electric field due to an electric dipole at any point on its axis, which is at a distance from its center varies according to. Here, this is also question directly from expression where electric field is inversely proportional to the cube of R. Thus, we concluded it. Thank you guys.